Hello, Geometry. This is Miss Redmond tuning in. So today we will be looking at the side-side-side congruence theorem. So SSS congruence theorem. So first, let's start with a little warm-up to review. So here it says, what property states that segment BD is congruent to segment BD? And so if you look at our diagram, that's the side that both of these triangles share, so we know that it is congruent to itself. And so the property that says that, and you guys should all know this and be able to answer that question, but it's the reflexive property of congruence. So this is an important property. If I were to ask you what this property is, you should be able to name it. Let's say I give you a theorem on your test that uses this property. I will not give this to you as a key. Alright? You will have to know that if I see something like this, I use this property. Alright? That's the expectation. I won't give hints about when to use that property. This is the time to review this, if you don't already know that. So, moving along, here it says decide whether the congruence statement is true. So, I'm just going to start by listing what I know. So, I know that QT, segment QT is congruent to segment TR. I also know that segment PQ is congruent to segment SR. And then finally, I know that segment PT is congruent to segment TS. So, now looking at this, I see that I have 3 pairs of congruent sides. So I have everything I need to know to use a side-side-side congruence theorem. And so, are these 2 triangles congruent? Yes. By the side-side-side congruence theorem. And that's exactly what this theorem says. If I have 3 pairs of sides congruent amongst 2 triangles, then I have 2 congruent triangles. Alright, so next it says determine whether the figure is stable. Explain your reasoning. So what does it mean for a figure to be stable? It means that it can't change shape. And so if I think about a figure, like my triangle is up here, that has 3 sides, I know that this is some length, this is some length, this is some length. If I have another triangle that is those exact same lengths, then those 2 triangles are congruent. Why? Because there's only one way to arrange those lengths. If I have, let's say, a length of 5, a length of 3, and a length of 2, there's only one way that I can have those lengths match up. Alright? And I don't know that those lengths are actually true for that triangle, but that's just an example. So when I look at these figures below and I want to determine if they're stable, what I'm really looking for is, are there triangles within this figure that allow me to use a side-side-side congruence theorem. So for the first one, there's no triangles at all. So no, this is not stable, and the reason is because I can have other quadrilaterals with these sides. It could be a rhombus, we don't know. So no, this is not stable. So a good application for this is if you're trying to build something. Let's say you're trying to build a bench, you're trying to build a frame for a picture, something like that, and you don't want someone to just like be able to push it over, you don't want it to just collapse, then you're going to have to give it support so that it's stable. So this would not be a very good design for whatever you're building. So the next one, I can see that I have 2 triangles and they satisfied the side, 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 and this triangle has 3 different sides as well. So I don't know that they're congruent necessarily, but they have 3 different sides. And so, yes, this is stable. If I look at this last one, I have a triangle here, so that's good. So I know this is stable. There's only one way I could arrange those 3 lengths. I'm going to use 3 pieces of wood, whatever that is. But if I look at this figure here, that is not stable. There's multiple ways I could arrange that. So, no, this is not stable. So again, for these examples, really what you're looking for is my figure made up of triangles? If it is, it's stable. If it's not, then it's not stable. So now here's a proof. Yay, more proofs, right? Okay, so it says given WZ is congruent to WX. I'm going to go ahead and mark that. WZ is congruent to double WX. And it says segment WY bisects segment ZX. So again, bisect means it splits something in half. It splits the segment XZ in half. So that tells me if it's being split in half, segment ZY is congruent to YX. Okay. Now, I'm trying to use a side-side-side congruence theorem. And so I need to show that my other sides of my triangles are congruent. So that's this side right here that they share. And you should remember from our warm-up that if I have 2 triangles that share the same side, I'm going to use the reflexive property of congruence. So that is what I'm going to use to prove this. So we have everything set up. We have our side, side, side for our first triangle and our side, side, side for our second triangle. So now I can go ahead and list my statements and my reasons. So again, I'm going to start with what I'm given. So I have segment WZ is congruent to WX. And then I also know WY bisects ZX. And my reason is because it's given. I'm sorry that you can't see what I'm writing while I'm writing because I'm left-handed. My left-handed friends will know the struggle, but just bear with me. You can also pause this video at the end of a proof and just take time to write it down. So the next thing we know is that ZY, segment ZY is congruent to segment YX. So we know this by definition of a segment bisector. So again, bisects is in my given. So I'm probably going to want to use that definition when I do my proof. Alright? If you have some vocab word as your given, you're going to want to use it. So that gives you a big hint for your reason. So my reason here, definition of segment bisector. Okay, number 3. I know that WY and WY is congruent to itself. And the reason for that, again, is the reflexive property of congruence. Alright, so if we look back, we satisfied 2 sides being congruent here. another two sides being congruent, and then our last pair of sides being congruent. So we have three pairs of sides being congruent. And so now we can say our final step, that triangle WYZ is congruent to triangle WYX. And the reason is the side-side-side congruence theorem. So again, if you need a minute to pause the video and get this copied, you may, but I'm going to move along. So flip over our page. We have another proof here. So at this point in time, I would like you guys to just pause the video, try it on your own first. Give yourself a minute to try it on your own, and then take 2 minutes to discuss as a group what you did. And then after that total of 3 minutes, you can resume the video and we'll work through it together. Alright, so let's look at this example together now. So here it says that JM, and this should be segments. I believe I had changed that on your paper, but if not, so if I fail to do that, make sure to change that to segments. So segment JM bisects KN. So remember, JM is doing the bisecting. And what's being bisected? KN. So that tells us that KN is the thing that's being split in half. So KL is congruent to LN. Alright, and then it says KN bisects JM. So now KN is doing the bisecting and JM is the thing being bisected. So I know now segment JL is congruent to segment LM. Then it tells me that segment JK is congruent to segment NM. Alright, so here I can see that my two triangles I have side, 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 and this triangle I have side, side, side congruent. So this is wonderful. Now I just have to write everything we said in the formal proof. So one, I start with my given, so segment JM bisects KN bisects JM, and JK is congruent to NM. The reason, because it is given. So step number 2, and we can actually combine this next step. You could separate if you would like, but we can combine it. So because we're using the definition of bisector twice, we can just write it as one step. So from the definition segment bisector, we are able to say that segment JL is congruent to segment LM, and segment KL is congruent to segment LN. Okay. So step number 3. Let's review what we have so far. So we know that these two segments are congruent. Oops, sorry, that's a little sideways. We know that our next two pairs of segments are congruent. So I have my SSS. Now I'm all set to use the side, side, side congruence theorem. And we can say that triangle JLK is congruent to triangle MLN. Alright. So think, pair, share. So if you can please, for the next minute, talk as a pair. So talk to your able partner about this question. Right? Pause. pause the video for a minute and then we'll bring it back. Okay, so here it asks, is it possible to prove that two triangles on the right are congruent using SSS? And if we label all the information we're given, you should have labeled that these two segments are congruent, these two segments are congruent, and these last two pairs of segments are congruent. So it seems like we can use side, side, side. However, notice that segment AF that we're marking as congruent to segment CD is not the whole side of my triangle there. It's just the little part of my triangle. However, this little part that is not included, this part right here that's not included, I know that both of those triangles share that length. That length is the same for both triangles. Right, so I could say that that little length from F to C is congruent for both of my triangles. And I could say the length DF is DC plus FC, and the length AC is AF plus FC. I know that these lengths here are the same. I also know that this length here is the same. So segment FG is going to be congruent to AC. So to explain our reasoning, I would say yes, and I would use the reflexive property of congruence to show that FC is the same for both of my triangles, and I would use the segment addition postulate. Remember, that's what it says, AF plus FC is equal to AC. Alright, so if you see a proof like that, that's how you'll kind of accomplish it. I won't give you a proof that challenging, but you're smarter now because you know this. So, moving right along, we have the hypotenuse-leg congruence theorem. Alright, so we're going to do another little warm-up. This is still 5.5, but we're talking about a different theorem, so we're going to do a different warm-up for it. So here's asking how long is segment AC. So here's segment AC, and how long is XZ. So you should remember that we have the formula A squared plus B squared is equal to C squared. If I square both of my sides, it's equal to my hypotenuse squared. So we could call AC A, we could call CB B, and we could call AB C. So if I complete this formula and plug in the values I know, I have A squared plus 4 squared is equal to 5 squared. So here I have A squared plus 16 is equal to 25. I subtract 16 over. 25 minus 16, I get 9. If I take the square root of both of them, I get A is equal to 3. Now notice if I use this formula for XZ, and I have A, I have B, I have C, I'm going to be plugging the exact same values to find my known length. XZ we're calling length A. And so we also get A is equal to 3. Our XZ is equal to 3. And here we could say AC is equal to 3. That A was representing the length of that side. So now that asks us, is triangle ABC congruent to triangle XYZ? Well, we said that A is 3, so I can go ahead and label that. And now I can see that, okay, those two sides are congruent, these two sides are congruent, and my last two sides are also congruent. So, yes, by the side congruence theorem. Alright. So here it asks us, what additional information would you need to prove the triangles are congruent using the hypotenuse leg postulate? So for the hypotenuse leg postulate, there's 3 things that are necessary to use that theorem. 1, we have to know that our triangle is a right triangle. So if you look here, we have to know that our triangles are right triangles. Then we have to know that one pair of our sides are congruent and that our hypotenuse are congruent. Okay, so this pair of sides are congruent, we call that our leg. The side opposite of the 90-degree angle, that's always called our hypotenuse. Okay, hypotenuse, that's represented by the H. The H is the hypotenuse, L is the leg. So I have my leg and my hypotenuse, and this is a right angle. I have my leg and my hypotenuse, and this is a right angle. We know that the corresponding parts are congruent. So we could use the HL congruence theorem for the example we did above. We didn't have to solve for A to be able to say that those two triangles were congruent. We could just use this new theorem called the hypotenuse leg congruence theorem. So in this example here, we see that two of our hypotenuse, at least we believe that's a hypotenuse, it's not very clear, because this isn't a right angle. We don't have a right angle there for sure. It kind of looks like it is, but we can't assume because it's not labeled. So we have two pairs of sides being congruent to each other. This is probably our hypotenuse, this is probably our leg, but we cannot say that these two triangles are congruent. We can't use the hypotenuse leg postulate because we don't know that these triangles are right triangles. So what's already known, that LN is congruent to AB and BC is congruent to LM. So this is probably, we said, our length, or not our length, sorry, our leg. Our leg, and this is our hypotenuse. Hypotenuse, I believe I spelled that correctly. Forgive me if I'm wrong. Wait, yep, I spelled it correctly. Alright, so what is needed? A right angle. Why? Because we need two right triangles. Okay, for the next example, what is already known here? Well, we have a right angle. So we have a right triangle. What is needed? Well, let's see. We also have two congruent legs. So an M is congruent to FE. So here we have our leg, but we don't have that our hypotenuses are congruent. So this is what I would need to prove in some way. So I need to show that DE is congruent to LM in order to use my hypotenuse leg theorem. Alright. So now we have a proof. So here it asks us, I guess it tells us, that segment AD is perpendicular to segment BC. So I'm going to mark that being perpendicular. And so here we have our two right angles, so we have two right triangles. And it says segment BA is congruent to segment AC. So mark that as well. And the other very obvious thing that you should notice is that segment AD and segment AD is congruent to itself, but we have to actually state that. So, from looking at this, we have our hypotenuse, we have our leg, and we have a right angle. We have our hypotenuse, our leg, and right angle, so we have everything we need. So let's get started. We have segment AD is perpendicular to BC, and segment BA is congruent to AC. The reason, because it is given. So, number 2, well, if segment AD bisects segment BC, then we know that angle BDA and angle ADC are right angles by definition. I guess I don't need to write by. Reason, definition of perpendicular. Statement number 3, well, let's continue off of this, because in order to use our hypotenuse leg congruence theorem, we actually have to say that those two triangles are right triangles, and we haven't said that yet. So because we know that both of these triangles have that right angle, that makes them a right triangle. So we can say triangle, and I'm going to use the order they give us here. Triangle ABD is congruent to triangle, or it's not congruent yet, we don't know that yet, sorry. Triangle ABD and triangle ACD are right triangles. So, the reason is definition of right triangles. Alright, and then finally we said that AD is congruent to AD by the reflexive property of congruence. So if we look back, we have our right angle, so that's good. We have our right triangles. We have that our hypotenuse are congruent. That was part of the given. And we just saw that our legs are congruent. So now I can use the hypotenuse leg congruence theorem to say that triangle ABD is congruent to triangle ACD. And I am running out of space. My apologies. Alright, so if you need a minute to write that down, you may pause it, but I'm going to move on. So, we have one more proof. It says given PQ is congruent to RS. So PQ is congruent to RS, that's already labeled for us. And it says angle Q and angle S are right angles. Very good. So far we have two right triangles. We have our two legs being congruent to each other. And now we just need to show that our hypotenuse, and again our hypotenuse is opposite of a right angle, we need to show that these hypotenuse there are congruent. But we know that because again we're using that reflexive property of congruence that we keep talking about. So we are set up to write our proof. So step number 1, write your given. So we have PQ is congruent to RS, and that is given. We also have given that angle Q and angle S are right angles. So now all we really need more from our proof is that PR is congruent to PR, and the reason, again, the reflexive property of congruence. So if I look back here, we just use the reflexive property of congruence to say that our hypotenuse are congruent. We know that our legs are congruent. Now it's tempting to say that we're done with our proof because we know that these are right angles, but again, we have to say that they're right triangles. So I have to take it a step further and say that triangle PQR and triangle RSP are right triangles. Okay, if you use the abbreviation for triangle, I'm okay with that. So, by definition of right triangles. And now this is the information that I need to say that triangle PQR is congruent to RSP using the hypotenuse leg congruence theorem. Oops, and I'm getting sideways again. Okay. The very last thing, think, pair, share. You can talk about this together again, a moment to just think about it, and then give yourself 2 minutes to talk about it together, and then bring it back to the video to find out what the answer is. Okay, so here and hopefully you discover this for yourself, but we want to agree with Angel. We want to disagree with Ray. Because if I have a leg-leg theorem, so let's say this is my two right triangles, and I have a leg-leg theorem, that's really not necessary because, yes, this is the same as side, angle, side, side, angle, side. Like maybe I'll make it a step shorter and then we don't have to say, well, because they're right angles, we know that they're congruent. But it's not really necessary. The reason why the hypotenuse leg theorem is necessary is because we can use it differently than we can use, let's say, a side-side angle theorem. Side-side angle. Remember that side-side angle is not allowed. You can rearrange it so it's ASS, and remember that is not allowed. ASS, spell it out, don't say it, but just remember no ASS. Alright? get your giggles out, whatever. But write your thinking here. I'll let you do that in your own words. Hopefully I've explained that well enough that you can get started on your homework. You have 5.5 homework for this. You don't have too many examples, but please refer back to your notes here. You can also look at the textbook for the examples of the proofs they have there. Use your resources, use each other. 5.5 homework is due on Friday. So you have the next few days to get your questions answered. Go to tutoring. Mr. Doyle is happy to help. He knows I'm not going to be there, and so he's not going to be surprised if there's a group of you who need your questions answered. Alright, please work hard while I'm gone, and enjoy the rest of your day. Goodbye.